In early 2010, NS SD60 number 6653 entered the Juniata shops in Altoona and became the first of 240 planned units of the SDE capital rebuilding program. This program allows 1980s and older locomotives to be rebuilt as compliant and more fuel-efficient locomotives, often at a lower cost than new locomotives. I'm Railfan AC, and you're watching Trains in the 21st Century. The EMD SD60 is a 3,800 horsepower 6-axle diesel-electric locomotive that was built by EMD that was intended for heavy-duty drag service. It was introduced in 1984 with production running until 1995. Prior to the 60s, EMD developed the 50 series 4-axle and 6-axle diesels in the mid to late 1970s into the early 1980s. The development of the 16-cylinder 50 and 60 series locomotives was spurred by the introduction of GE's Dash 7 line, particularly the 3,600 horsepower 16-cylinder B36 and C36-7s. On that note, EMD had previously manufactured the 3,600 horsepower 20-cylinder SD45 and SD45-2 locomotives. In 1980, the SD50 model was added to the EMD catalog. EMD had pushed the 645 prime mover further than it had ever been pushed, to 3,500 and eventually 3,600 horsepower. The extra power was sent to the new D87 traction motors that boosted the continuous ratings by more than 10% as compared to the older D77 traction motors. But their electrical reliability was poor, and similarly, the 3,600 horsepower engine had poor mechanical reliability, which was believed to be mostly due to excessive vibration from the 950 RPMs of the 645F prime mover. It was time for a replacement for the 645 engine, which, in its earlier 16-cylinder, 900 RPM maximum form, had proved to be exceptionally reliable. Because of those reliability problems, the 50s never really replaced the wildly successful 40 series locomotives that came before them. Because of that, EMD never took the 40 series engines off of the book, so it's ironic that both the 40 and 50 series locomotives were sold side by side during the life of the GP50 SD50 production. The last GP40-2 and SD40-2 orders came after production had ended on the 50 series in the mid-1980s, and in total, about 278 GP50s went to 5 railroads, with approximately 487 SDs going to 12. And in addition to the standard production model, the 50 series diesels had a couple of unique designs. The first was the GP40X, which had the high adhesion HTB trucks under the SP and UP built versions. The new trucks were designed to address several issues with older truck designs, but were never ordered by a railroad. We'll talk about these locomotives later in the video. To get back market share lost by the 50 series diesels, EMD quickly commenced development of the 60 series, which would eliminate the weaknesses of the 50s. The lessons learned in developing the 645F crankcase and crankshaft for the earlier SD45 and then current SD40s were incorporated into the replacement, the 710G, which was first employed in the SD60. And although the car body and frame was nearly indistinguishable from the earlier SD50, the SD60 featured the new 16-cylinder 710G3A prime mover, AR11 traction alternator, D87 traction motors, and a microprocessor-based control system that governed various electrical systems within the locomotive like wheel slip and transition. And speaking of transition, it was a transitional model, as the 50s were the last to use the 645 engine and the first to use the new Super Series wheel slip control system. The use of the Super Series of the SD50 was implemented just before the microprocessor era began on the 60 series locomotives. To develop the 50 series diesels, EMD made 4 and 6-axle prototypes, 23 GP40Xs in late 1977 and early 1978, and 4 SD40Xs. We talked more in depth about these locomotives in video T-176. There's a link in the description to that video, just in case you missed it. Both were way different from their 40 series predecessors. The GP40X had flared radiators like the SD45s, and almost half of them rode on the new HTB truck design, while the SD40X had a longer long hood to accommodate the relocation of the dynamic brakes from above the engine to behind the cab. Both were built on the same frame lengths of the GP40-2 and SD40-2 except for the 6N&W SD50S models, which were about 2 feet shorter than the production SD50s. The prototype 50s were built and painted for the railroads they would test on, with 4 GP40Xs going to the Southern Pacific, 6 to the Union Pacific, 10 to the Santa Fe, and 3 to the Southern Railway. The 4 SD40Xs were painted for the Kansas City Southern and were delivered to them in 1979. The Southern Pacific GP40Xs also had the experimental elephant ears over the radiators, drawing cooler air near the frame while the units ran through tunnels, again like we talked about in video T-176. Another oddball SD50 was a single order of the 4-width car-body SD50Fs for the Canadian National, and Burlington Northern had 5 GP50s with larger cabs to accommodate extra crew members in the mid-1980s when cabooses were being eliminated off of trains. Designed but never built, the Rio Grande had, in theory, a GP50T which used the successful SD40T-2 tunnel motor radiator design. Today, a few short lines still use GP50s and SD50s, and 3 of the 7 Class 1 railroads still roster 50 series units: BNSF, CSX, and Kansas City Southern, the latter 2 being original purchasers of that model. KCS had the SD40X and SD50 models, and all of the original units have been retired. The 17 or so SD50s that still reside on KCS today are former Conrail units. CSX has the largest fleet of SD50s still hanging on a Class 1 railroad, with about 162 remaining. Of those, only 4 remain in their as-built configuration, with most being modified to either -2 or -3 electrical systems and reduced horsepower ratings. We talked about these diesels in full detail in video T-146. There's a link to that video in the description, just in case you missed it. BNSF's 2 predecessors were both big buyers of the Jeep 50s, and all 10 of the original Santa Fe GP40Xs are still in service on the BNSF to this day. With that in perspective, it comes as no surprise that the BNSF has the biggest fleet of Jeep 50s at about 116. Many of them have upgraded electronics and or have been derated to either 2500 or 2950 horsepower. The re-rated Jeep 50s have been reclassified as Jeep 25s and Jeep 25Xs. The upgraded Jeep 50s are now called Jeep 50-3s. In 2017, BNSF bought 2 more Jeep 50s that were cycled through their Topeka, Kansas shops and released for service. This brings us to the primary subject of this video, the later SD60. The SD60 was more reliable and fuel efficient than the SD50 was. Unfortunately, it did not put EMD back on top of the diesel locomotive market despite being offered in a variety of configurations. The SD60F was another Canadian National oddity that has the 4-width cowl body and a crash-worthy safety cab with a 4-piece windshield. Pretty much an SD50F with the 710 engine, the CN retired their 60Fs in 2017 with a handful of them sold off and still working today on a short line in Minnesota. The SD60M has a North American safety cab. Up until about 1990, the early 60Ms had a 3-piece windshield with vertical windows that were nicknamed the Triclops. These were identical to the windshields found on the Canadian Pacific SD40-2F and F59PH models. Later production from 1991 on used a 2-piece teardrop windshield configuration that was slope-backed and had a shorter tapered nose. Buyers of this model included Conrail, Union Pacific, Burlington Northern, and the Sioux Line having the Triclops. The SD60i has the EMD whisper cab that was insulated from sound and vibration by a system of rubber gaskets. That same cab is on the SD70i, the SD75i, the SD80 Mac, and the SD90 Mac locomotives. Only Conrail ordered the SD60i, and all now belong to CSX and NS. The SD60 Mac is identical to the SD60M except for the AC traction motors. 4 demonstrators were tested on the Burlington Northern and proved the viability of EMD's AC traction, yet all future orders were for the SD70 Max instead. The SD60E is a custom rebuilt SD60 created by Norfolk Southern at the Juniata shops. So far, only standard cab SD60s have been rebuilt with the new NS-designed Crescent Cab. The name Crescent comes from the Norfolk Southern Crescent Corridor, which runs from Louisiana to New Jersey. The upgrade included new electronics and engine upgrades to the 710G3B that's now rated at 4,000 horsepower. The goal of NS was to build around 250 E models, so NS bought additional SD60s from Helm Leasing specifically for the program, but only 135 were built, and the project was terminated in favor of the AC traction rebuilds of the SD70 and the -944CW locomotives. The SD60s that weren't rebuilt were retired and sold off in 2019. Notable SD60Es include the NS number 6920 Veterans Unit, the NS number 6963 Go Rail Unit, and the NS number 911 Honoring Our First Responders Unit. SD60E engine upgrades have improved fuel efficiency by about 7% compared with the original SD60 engines. That translates to annual diesel fuel savings of 15,000 to 20,000 gallons and about 220 fewer tons of carbon dioxide emissions per locomotive. For 60 SD60Es, that amounts to annual savings around 1.2 million gallons of diesel and about 13,340 tons of carbon dioxide emissions. In December 2013, Norfolk Southern received a U.S. patent for the design of one of the SD60's key engine enhancements, a dual-circuit engine cooling system dubbed split cooling. Don Faulkner and Bill Thompson were the brains behind the system. In another key development, the EPA in May of 2013 issued Norfolk Southern a certificate of conformity that will enable the company to build and install custom-made emission kits for the SD60Es. The SD60Es feature engine technologies that achieve optimal fuel economy while reducing emissions. Similar upgrades are incorporated into the rebuilds of other NS locomotive models. Here are 6 key enhancements that put the E on the rebuilt SD60Es. Electronic fuel injection, dual circuit engine cooling, automatic engine stop-start, larger crew cab, leader, which means the Locomotive Engineer Assist Display Event Recorder Train Handling System, which is being installed on all Norfolk Southern long-haul locomotives. The GPS-based system calculates and displays in real time the optimum train speed for achieving maximum fuel efficiency. And the 6th enhancement, positive train control. NS's rebuilding program is giving new life to locomotives built from the 1970s to the 1990s through a combination of recycling and modernization. Existing steel platforms, wheel assemblies, traction motor frames, and engine blocks of these older locomotives are reused. The engines are upgraded with reconditioned parts and digital era technologies that improve fuel efficiency and reduce emissions, including carbon, particulate matter, and nitrogen oxide. The made-over locomotives are known as E models for enhanced. Mechanically, the original prime mover, a 16-cylinder 710G3, remained but was thoroughly rebuilt to 710G3B specs and re-rated to 4,000 horsepower. The original shaft-driven air compressor was replaced with a new motor-driven compressor. All new electrical cabinets and wiring coupled with EMD's EM2000 microprocessor controls was installed along with D99 BTR traction motors. The new split cooling system helps the SD60E meet Tier 0 plus emission requirements and reduce fuel consumption by an estimated 5% as compared to an older SD60 model. The SD60E's tractive effort is rated at 109,000 pounds while an unrebuilt SD60 is rated at 96,000 to 100,000 pounds. Externally, while most of the SD60's car body remained intact, the program included the installation of a completely new cab which provided crews better crash protection. The original SD60 cab weighs 3,800 pounds compared to a whopping 12,500 pounds for the Crescent Cab, although a more spacious work environment is available with the new cab. The cab was designed by NS with input from outside consultants and train crews. Fabricated by Courier Railroad Supply, it looks unlike anything else on U.S. rails with its pronounced number board headlight housing and flat front with the centered cab door. The first unit was finally released for service on November 15, 2010, carrying the road number 6900. In March 2011, 6901 was released, followed by 6902 in June of that same year. These 3 units gave NS mechanical personnel valuable feedback as the units toured the system and during real-life testing. In March of 2012, the 4th SD60E emerged from Juniata as one of the 12 units that was initially funded for the program, but the pace of the remanufacturing process picked up as initial teething problems were addressed. The units soon met the carrier's expectations and began entering revenue service on a regular basis. The end result of the rebuilding program are more cost-efficient, cleaner burning, and more user-friendly locomotives for train crews that will serve the railroad for another 15 to 20 years. With these rebuilds, the company is reducing operating costs and impact on the environment. In 2013, the employees at the railroad's two heavy repair locomotive facilities, the Juniata shops in Altoona and the Roanoke shops in Roanoke, worked on rebuild projects that spanned a half a dozen locomotive models, including yard, local, and line-of-the-road engines. The rebuild program includes locomotives remanufactured by the two largest locomotive builders in America, Locomotive Diesel and GE Transportation. In addition to the SD60Es, Norfolk Southern's other locomotive rebuilds include the SD40E. These 3,000 horsepower units, rebuilds of 1980s EMD SD50 six-axle diesels, are used as helper engines in mountainous terrain and on maintenance-away work trains. They're equipped with the new microprocessor control systems and upgraded engines. The SD40Es are reliable workhorses that burn less fuel with their reduced horsepower engines. GP40-2 and GP40 mother slug sets. These combo units are rebuilds of 1970s and 1980s EMD Jeep 38 and Jeep 40 locomotives. The slug units do not have engines but are equipped with traction motors to provide propulsion power. The slugs are filled with concrete and are paired with 4-axle Jeep 40-2 mother units featuring reconditioned 3,000 horsepower engines that provide electrical power to turn the traction motors. Together, a Jeep 40-2 and companion slug can provide nearly the same pulling power of two 2,000 horsepower Jeep 38-2 locomotives at slow speeds while sucking down 40 to 45% less fuel. Now that's efficiency. The GP59E mother units. These rebuilds of the 1980s EMD GP59 units are intended for yard work and local delivery runs. They feature a new microprocessor control system, electronic fuel injection, a low emissions engine, and the patented split cooling system. The MP15E rebuild of the 1970s and 1980s EMD MP15 DC units are used to switch rail cars in yard operations. They are being upgraded with electronic fuel injection to increase fuel efficiency and reduce emissions. The company has also developed a turbocharged prototype MP21E locomotive with a 2,000 horsepower engine that competes with the GP38-2 model. Some MP15Es have already been sold off by Norfolk Southern. The GE-8.5 40CW is a 6-axle, 4,000 horsepower road switcher diesel-electric locomotive originally built by GE Transportation Systems and was rebuilt by Norfolk Southern at its shops in Roanoke, Virginia. The first locomotive started rebuilding in 2012. These rebuilds of 1989 and 1990-8 locomotives are the first rebuilds of older GE diesels. The first of the 4,000 horsepower 8.5 units rolled out of the Roanoke shops in 2014. The units feature enhancements similar to those on the SD60Es. They were also being equipped with the novel AC power feature that would convert them into mobile generators for use by the rail terminals that lose power during hurricanes or other storm events. The locomotive is designed to meet Tier 2 emission standards. All of the -8.5s, excluding the 8500 and 8505, have been rebuilt with the Norfolk Southern designed wide-nose RLS cab, which meets current FRA crashworthiness standards. The 8500 was rebuilt with an STE style cab, while the 8505 was rebuilt with an ES44 AC style cab. They've been equipped with the traction and engine control unit from TMV Control Systems, upgraded from manual fuel injection to electronic fuel injection, and equipped with the NS-designed split cooling system. The rebuild also includes the installation of locomotive speed limiter and cab signals. The traction motors were upgraded from the GE752AG to GE752AH. They were also equipped with the CCB26 electronic air braking system and an electronic parking brake. PTC has also been installed. 84 rebuilds were originally planned with the units being electronically comparable to the -9s, but the initial testing of the rebuilds found them to be far from satisfactory, so the units floated in and out of storage for modifications only to be sidelined yet again. NS has since canceled the -8.5 rebuilding program, retiring the remaining -8 fleet and instead focusing on their DC to AC rebuilding program. We talked about the NS E-Class locomotives in an earlier video, T-116. A link to that video is in the description, just in case you missed it.